All right. Hey, everyone. Thanks for the introduction. I'm Jonathan from Talisman, if you don't know me. And today I'm going to be giving a presentation titled The Application Layer, where the point really is to bring Sub0 into the browser environment and kind of give some tips and tricks for how to build performant applications on Substrate with Talisman inside of the browser. If you don't know me or the team at Talisman, we're a product-oriented team helping users kind of traverse the ecosystem with 3 products. We've got a well-known extension wallet and a web portal, and a less well-known multi-sig suite, but hopefully that's a little bit more known at the end of Sub0 because there's a good talk on tomorrow, I think, so watch out for that. So this is like a sister talk or a sibling talk of something I gave at Decoded last year, where I essentially had this really rudimentary picture of the tech stack that exists in the Substrate ecosystem. At the bottom, you've got kind of low-level technologies like P2P and networking. You've got the Polkadot protocol, cores. I don't know if that's like parachains or core jam or something like that, so we'll put cores for now. Some middleware, and then right before the user, you have the application layer. This is where Talisman is. This is our domain. And at Decoded, I kind of spoke about what is the role that the wallet has to play, being the last step in the stack immediately before the user. Because today is the developer conference, I wanted to kind of do a sibling talk and instead talk about how you guys can perform the role of building great dApps and products also in this application layer with some stuff that Talisman have built and also some really important principles that exist further down the stack. So in the next 20 minutes, we'll do some let's say housekeeping items for the first 2 bits. This is some utilities that we've built recently that might help you guys iterate and test the products that you're building inside of the application layer on Substrate. Maybe a little bit on how you can go to market really smoothly with your application. And lastly, the frequency of grand statements and hand waving will increase as I talk about how you can build a resilient application kind of with Talisman and with Substrate in the application layer. So let's get into it. This is something that we built for ourselves, signed in with Substrate earlier this year for our multi-sig project. And those familiar with the Ethereum ecosystem might know what this is. It's like an equivalent to the sign-in with Ethereum protocol that exists in that ecosystem. But we've built this standard for Substrate key pairs recently. It's pretty simple. It's essentially a standard for authenticating a Substrate Polkadot signature with your SR25519 key pair against the backend. So the users can connect their wallet to an application, select which account they're going to be signing in with, sign a message to authenticate against the backend, and then they kind of receive a JSON web token that allows you to use some protected API because you've authenticated with your self-custody Substrate account. So this is a very kind of primitive utility for people to use in lots of different ways, but something that I want to highlight as a use case for this is it's essentially anywhere where you want to combine off-chain data with on-chain data. And something that I think is maybe worth exploring a little bit is using a tool like this to find product market fit in the application layer. The application layer is where you should do things like battle test your product idea in the market, break things really, really quickly, fake it till you make it. And you can essentially be like a pre-runtime project, test out your business logic by getting the user to sign into some application, perform kind of signed message requests with something like sign in with Substrate that's essentially mocking the runtime code that you intend to build. And this is a good way of validating maybe your business case, validating your product before you spend many, many hours and lots of pain kind of building a runtime. You should really battle test your ideas before it gets to that step. And a utility like sign in with Substrate might be a good way to do that inside of the application layer. So you're not wasting time re-engineering what you're doing further down the stack when you realize that maybe users want something different or they don't want to use it in the way that you've built it. There are other things you can do with sign-in with Substrate. We've built it for our multi-sig product, the Polkadot multi-sig or Signet. This is for sharing the call data between the signatories. But you can basically use this for anything where you might not want to store data on chain, like some auxiliary or frivolous data that's useful in your application, but not necessarily kind of the type of thing you want to put in storage. You can just whack this in a backend, get the user to authenticate with a signature. Hi, I'm Jonathan. This is my account, and then you kind of use that protected API. We've got a TypeScript implementation on npm and Yarn. There's the package name. And to give you an idea of what's in like the sign message type with sign-in with Substrate, here's everything that's there. It's pretty generic. You can basically use this however you like. So lots of applications here, but it's a really useful primitive, I think, mainly for finding product market fit with your products before you start hacking on runtime code. I think that's a really useful utility for the ecosystem, maybe something that we need to see more of. We've got some good documentation and also all of the support channels you'd expect on Element and Telegram if you want to contact the team behind sign-in with Substrate. Another like primitive that we've built inside of the wallet that you might want to consider using inside of your product that you're building in the application layer on Substrate is something that we put in for a project specifically in like late 2022. But they didn't end up using it. However, it's in the wallet now, and you're free to use it inside of your applications. It's just the ability to encrypt and decrypt strings using the key pairs inside of the Talisman extension. So the API is super, super simple. There's documentation available for this as well, but you can see that it's quite a simple API just to specify who you're encrypting the data for, and then signing that with your key. And then if you're the recipient of the data, you can kind of build your application pretty simply and allow the user to decrypt whatever message was intended for them with their key pair. This is something that I don't think anyone's used yet, and it's another useful primitive that you might want to leverage for like a messaging application or an encrypted message board. Lots of different things you could do with this, and yeah, available for anyone to use. Moving on to asset and network support. So let's imagine you've built your application inside of Substrate, ready for launch. You've done the product market fit finding, I hope, and you have a really polished product ready to go, but you need some seamless wallet support. So the users arrive at your application, and the assets that they're given inside of your application are reflected inside of the wallet nice and easily. This is something that we do in Talisman, I think, pretty seamlessly with our chain data repository. You can find it here on GitHub. It's essentially just a big repository of all of the metadata that you need to get support for your network and your assets inside of the Talisman wallet. So you can give us things like any of the endpoints you're using, the key pair type that your chains implement, any information about assets, both native into the balances palette or non-native if you're using other palettes, existential deposits, block explorer links, logos, everything you would need to support or like to expect support from a wallet, you can add to the chain data repository. And I think the beautiful thing with this is it just works seamlessly. Like once you add this to chain data, it's instant for every single user that uses Talisman. There's no coaching your users through like toggling support on and off for different networks, like there are for different wallets in the ecosystem, or adding contract addresses like there are for other ecosystems. But I will caveat that if the user wants some granular control over which RPCs Talisman is using to retrieve metadata or kind of send transactions that we craft, they're totally free to do whatever they want. We don't want this to be something that's kind of locked into whatever is defined inside of the chain data repository. So yeah, go to market with Talisman. It should be really, really smooth. It's like a 5-minute PR, and then you can have instant asset support and not have to worry about coaching your users through like programming the wallet to see the assets that you've given them. Okay, this is where the hand waving increases a little bit more, because I want to talk about maybe an important step that you can take when you're building your product inside of the application layer on top of Substrate, and that's to light clientize your application with the browser-embedded light client small dot, or the library that exists, Substrate Connect. So the current kind of setup with libraries that exist inside of applications in the browser on Substrate, and then the wallet and the network, is that the application actually has the responsibility of defining the user's connection to the chain. So the wallet is only asked to sign the call data. We don't do anything more, anything less. It's really quite like an offline procedure. Anything that is shown inside of the application is pulling from the connection that the DApp has defined. That is your responsibility. And also propagating the transaction to the network will be made on that connection as well. So this is like something that you have to bear at the moment with the way that applications are currently set up inside of Substrate. I don't know if this is going to change with Joseph's work on Pappy, but currently with Polkadot.js, this is the situation you'll find yourself in when you're building applications in the browser on Substrate. And currently, you're probably just going to say, I want to connect to that node. I'm going to give it an endpoint and say, let's let my user communicate to the network. All of the traffic coming down and up is just kind of communicating via one node that I have defined. And that's fine, because our node operators do a pretty good job in the ecosystem. I think we've got a really good selection of infrastructure providers. But what you could do instead, and this is what I'm pitching to you today, is to integrate Smalldot and essentially run a browser-embedded light client inside of your application. So the user suddenly becomes their own peer on the peer-to-peer network. They might connect to like 40 to 50 peers once this is synced up altogether. And this means that you're not kind of dependent on the one node provider that you've defined. The user is now communicating to the network kind of as a participant of the network. This is a devilishly simple change to make. This is the kind of code you might have for defining the connection between the DApp and the chain with a node. You just provide the endpoint pretty simply. We're using WebSockets here. And all you need to do using the Substrate Connect SDK at the moment is, if it's a well-known chain, you can basically get the chain spec from the Substrate Connect repository, and then connect, and it should sync up. There might be some like errors you have to handle and things like that, but it should happen pretty quickly. And it's like a 30-minute change that really increases the resilience of your application. And then you might be wondering, this is a load of rubbish. Like, why would I kind of go through this effort when the node providers that we have are pretty good? They all update their beefy keys on time, I hope. So what's the point here? It's working 99.999% of the time. This isn't really like an improvement that I should worry about making for my application on Substrate. Well, I'd say to you that it works all the time until it doesn't. No one is immune to mistakes, and you don't want your users left in a position where they are denied access to the network because you've just kind of defined it through one provider. You should make this change. And the kicker is that it's free resilience, right? The cost to the user and like the cost to your experience inside of your product in the application layer is negligible. The user is not going to notice that they're a peer on the peer-to-peer network if you're running a browser-embedded light client with Smalldot, or if they are just connecting via a node. It's like free from the user's perspective if you're only running one chain at a time. I'll caveat this with Pappy is kind of, I hope, nearing completion, and they are taking a Smalldot or a light client first approach. So maybe the way in which we integrate browser-embedded light clients into our applications changes. But the previous model, which we've shown here, was devilishly simple, and I'm pretty confident that Joseph will make it just as seamless to integrate, because it is free resilience. This is why we're here building products in Web3. There's no point having all of these amazing properties of censorship resistance, verifiability, permissionlessness, kind of further down the stack, if those properties come up and it hits the application layer where you've built your product, and then suddenly it's like, okay, we're just going to go through this like centralized provider. There's not much point. We need to preserve the properties through the application layer so that the user receives them. All right, so we've gone through trust assumptions with the network. You can run a browser embedded light client and kind of mitigate some RPC risk. But what if there's trust assumptions on the DApp? You know, the DApp might be malicious in like the worst case, or it's just done a crappy job with like displaying information, and it's a confusing experience. You might not want to. You might be kind of submitting a transaction that you didn't intend on submitting. The staking dashboard that Ross has built is great. That's just an example. But yeah, there's always some trust on the DApp. So how is this maybe mitigated in the application layer on Substrate today? It's actually something that Talisman has taken a crack at, where we are moving from the relationship between the DApp and the wallet being just signing, here's some cool data, apply a signature to it and throw it back, to the user might be asking the wallet for not just like a signing capability, but also the ability to verify the contents of the transaction that the DApp has just proposed. So what we do in Talisman is we ask the chain, hey, what's the latest metadata? And we take that, and then we take the call data for the transaction that the DApp has proposed, and we decode that transaction and display in a human-readable, hopefully digestible format for the user to then kind of verify, yes, this is roughly, or this is exactly the same thing that I kind of crafted on the DApp, and I want to apply a signature to it. It sounds pretty obvious when I say the user should verify the contents of their transaction before it gets sent to the immutable chain of transactions, right? But it's surprising how many wallets kind of don't perform this step. I think it's important. And it's totally separate to what the DApp is doing. So there's a kind of a check and balance there. Now these like human readable properties we show, there's the call data down below that has like some of the arguments and the function signature. But we also show the palette like documentation that exists in the Rust like implementation. And this is like pretty variable in how human readable it is. So here we've got a batched extrinsic to join the Talisman nomination pool. We're kind of joining the pool and then setting the claim permission so that somebody can auto compound their rewards. And batch is maybe an okay example because the clue is in the name of the extrinsic, what it's doing. But you can see here that the description that they've defined in the Rust documentation of the palette is just like, I'll see this other thing. So clearly, maybe the developer here wrote this not realizing that this information does come up to the application layer, and it is often used by a user to verify the contents of their transaction before they sign it. So maybe like a small call to action to any folks that are writing palettes and writing Rust docs is to keep in mind that this information should be kind of seen by a user when they're about to kind of execute that call. It's important. If you're writing palettes that become really well used, like the XCM palettes, Talisman can kind of go one step further. Instead of showing like a bit of a rudimentary kind of rundown of what we've decoded in the transaction, we can actually say, all right, let's take the call data, decode it, and then use that to create a really digestible screen that's incredibly easy for the newest of users to verify what their transaction is with like some custom UI. So this is what we have for all of the XCM palettes, but we've got similar screens for staking and governance and other common operations inside of the ecosystem. And I think this one I pulled from Moonbeam, because Moonbeam have deployed a precompile as a contract on their chain. And we can also do the same thing on EVM if the call data is matching. So we're at a position here where the RPC risk is mitigated by using a browser-embedded light client. Risk of the DApp being either malicious or like not being clear with the information that it's showing is mitigated with like an external verification or like kind of human readable description of what the transaction is inside of the wallet. But what about the wallet? You know, you've got to trust us now to decode this information correctly and show it correctly. We are now maybe like the point in the cycle where you're implementing some trust. Well, hopefully this changes a little bit. Basti has an RFC open at the moment. It's just gone to voting, RFC 78. This is included to support the new generic ledger application. But essentially, it's saying transactions now have to have a signed extension that includes some like shortened version of the metadata and the hash of the metadata that was used to decode the transaction, along with the call data, and then that's sent to the chain. And if we have used an incorrect version of the metadata to decode the transaction and show you something human readable, the transaction is going to fail. So now we're at a point where you don't need to trust the RPC, because I hope you've integrated browser embedded-like clients. You don't necessarily need to trust the DApp to show information correctly, because the wallet will kind of decode and allow you to verify yourself the contents of the transaction. And then you don't necessarily need to trust the wallet to do a perfect job there, because there is a little bit of a check and balance where if we've used the wrong metadata to do that, the transaction will fail on the chain. So this is a pretty resilient application layer, I think, and something that's enabled by the work that was done on the browser embedded light client, and also like the metadata standards that exist on Substrate. So this is pretty excellent. I know the conclusion here is that all the user has to do is use the DApp correctly and then verify themselves the information correctly. And depending on your perception of like the intellect of the average crypto user, this is like either good or bad. But I tell you what, it's a hell of a lot better than the alternative where they still have to do that and then trust all of this other stuff. So we have a really resilient application layer, or like the potential for a very resilient application layer inside of Substrate. And that's really exciting because there's all of these principles of trustlessness and censorship resistance and permissionlessness that exist down the stack. And as I said before, it's kind of pointless and a little bit sad if that's lost when you've built a product that doesn't inherit those properties and pass it on to the user as the folks that are in charge of kind of defining their user's relationship with the network. Okay, so wrapping up, you should be able to expect the following building in the application layer on Polkadot right now. You can battle test your products to make sure that they're coming to market with product market fit. No screwing around, writing lots and lots of runtime code only to find that it's not that popular and that there was something wrong with your business logic. Just mock this up, break things inside of the application layer using some utilities that we've built, or using however method you want before you get to the stuff that's harder to change. Launch time support from Talisman and all the other wallets. This is something that's also like enabled with the way in which palettes are defined on Substrate and allows a really seamless kind of go-to-market process for everyone building their products on Substrate. And you can build resilient applications. Because what's the point of building a Web3 application if it isn't resilient? Like, this is the axis on which our products and tools should be most competitive. Like, you might want to compete on how beautiful your product is, or how useful it is. And that's great when you're competing with kind of Web2 alternatives. But something where, like a property where every single application built on Substrate should excel is its resilience. And this is something that's maybe most reflected in this ecosystem compared to others. I'm kind of making announcements on behalf of other people here, so kind of go to the source. But there's maybe some changes to the DevX inside of the application layer for Substrate. Pappy is coming along. This is like a replacement for the Polkadot.js API. So that should be something to watch out for. And that's, again, it's kind of small dot first. There's proposals and conversations about the account or the address formats being a little bit more standardized. So maybe you don't have to contend with different prefixes on addresses and have to kind of coach your users through that experience. That might be getting better. There's a generic ledger application coming, and there's a talk on this. This is the asterisk items. This is another area where you don't have to kind of coach your users through some complexity that might exist now. Building products in the ecosystem, this should be getting a little bit easier to use in the future. And excellent multisig support is coming with the Polkadot multisig by Signet by Talisman. there's a talk on this tomorrow, and you should come to that because we've kept it under lock and key a little bit, and there's a big talk to explain what we've built tomorrow. So look around for Chris and Ghost and everyone from the team for that. And then there's changes coming further down the stack with the parachains protocol is being nuked and auctions are being nuked, and we've got core time, core play, and core jam coming sometime soon, and I'm sure that that's going to have some ramifications when you're building your products inside of the application layer. So we'll see what happens there. Maybe that's like a conversation for next Sub0. But yeah, I think the opportunities are available to folks to build really performant, really excellent applications on Substrate with what the Substrate ecosystem has built and what we've built at Talisman. So yeah, really optimistic about what you guys are going to build. Here's some contact details if you want to reach out. Thank you. Enjoy the rest of Sub0.